Nice question here. We've got 1 over x plus 1 over y is 1 over 20. What is the maximum possible value of y? Okay, now you can't just look at this straight away and say, right, y is going to be one of these. I mean, you could try these out, I suppose. Yeah, that is one way of doing this question, like substitute in 480 as your starting one and see if it can work. But let's not use that approach. Let's try and do it so we could solve the problem even if we didn't have multiple choice. What I'm going to do is get rid of these fractions. I'm going to times through by xy, both sides. This is equivalent to timesing each term by xy. So xy over x plus xy over y equals xy over 20. And now the x's cancel here, the y's cancel here. We've got y plus x equals xy over 20. So the next thing I can do is times through 20y by 20. 20y plus 20x, let's just see where this goes, equals xy. And I'm going to make y the subject. If I can get y in terms of x, and I can start to think about its maximum value. So I will minus 20y from both sides to give me xy minus 20y equals 20x, and factorize out the y. So x minus 20 times y is 20x, which means that y is 20x over x minus 20. Okay, there's a little bit more to do now. There's a little thing we need to think about. We need to basically try and get rid of this x at the top, because at the moment, how can we look at the maximum value of y? We want to basically think about, well, you might be able to get it from here, but let me show you a method that will work really well. We can first of all just say that it's 20 times x over x minus 20. Now here's the trick. We can minus 20 from x, and we can also add 20 to it. So it's not actually changed the fraction. And I can separate it into two different fractions. Note that the whole thing is still being times by 20. And the reason that that is useful is that this just becomes 1. So I've managed to turn it into a much simpler fraction. I'm actually going to get 20 plus 400 over x minus 20. So to maximize this, I want to maximize this, which means I want to minimize, because I'm dividing, I want to minimize x minus 20. So max y is when, and x has to be a positive integer. So the most it could, well, the least it could be is 1, but then I'd be minusing something. So I want to make x minus 20 as small as possible without it being 0. So I want to make x minus 21, and then x minus 20, yeah, x is then going to equal 21. And that will give us y equals 20 plus 400. This is achievable. We can't do any better than that, which gives us D as our answer. So you could arguably work it out from here. You might think, right, I want to make x 21 to, so I'm only dividing by 1, but it's a little bit less clear. Like, how do we know that, an x that was, say, 22 wouldn't work out better? So I think it is best to kind of learn about this approach. You would have got away with it. And of course, you would have got away with it if you'd started with this one, seen that it didn't work, and then you'd probably try this one and see that it does work, and then that would be the answer. But this is a more complete solution to the question.